Hello and welcome to my channel. In this video I'll be covering filter. So in this problem set, what we're supposed to do is implement some editing algorithms into our program, and we are supposed to specifically implement 4 editing algorithms. We're supposed to implement grayscale, where we turn images into black and white. We're supposed to implement sepia, where we're supposed to make an image look old, and then we're supposed to implement reflect, where we reflect an image to be like a mirror reflection, and then last and not least, we're supposed to implement blur. So let's get started. Let me just download the distribution code and we can begin. Alright, so here we have filter, and the file that we are supposed to complete is gonna be helpers.c, which is gonna be used in our main program. So there are quite a few things in the other files that are given to us which isn't very important, but I'll quickly just run over it. As for this file, the more important part is just this structure that we have created that we'll be using in the other files. As for filter.c, here is some of the algorithms created by CS50 itself, just to validate the input by the user. And then the important part that we have to take note of is this area where we have a switch case, and this is where depending on what the user has entered as a command line argument, either G, S, R, or B, we're supposed to edit the image. Alright, and then we have helpers.c, and this is where we are gonna implement our code. And then we have helpers.h. This is the header file, and this is how we will be importing the code that we have here into the filter.c. As you can see here in filters.c, we are including helpers.h, so we are including this so that we are able to use helpers.c. And for makefile, it's just to make sure we compile all the files, because in this program we are not only using one file, we are using multiple files, and just to compile all of them together, they have done some modifications for us, not very important for us to know at the moment. Alright, so now let's get started with the code. So the walkthroughs given to us by CS50, made by Brian, was pretty helpful. Alright, so like for example in grayscale, they told us exactly what is the algorithm we are supposed to use. Okay, so he mentioned that we can take the average of all of the RGB values, so red, green, and blue. We can take the average and just make sure the average is added, and make sure the average is basically the input to each of the RGB values. So as you can see here, the original was 50, 190, and 90, and the average comes up to 110, and this 110 is being input into the new RGB values for all red, green, and blue, and then we get a shade of gray. So let's do that. How we'll be doing it is using a for loop to index into every single pixel in the image, and then finding the average value for RG for red, green, and blue, and then to update the red, green, and blue values to all be the same, which is gonna be the average. So let's do that. For int I equals to 0, I is gonna be representing the height, so I less than height, I plus plus. So I is gonna be just indexing through the height of the image, and then we have for int j is gonna be indexing into the width, j less than width, j plus plus. Alright, and now we want to find the average. So how we find the average is to add the original red, green, and blue and divide it by 3. So int average RGB is gonna be equals to image I j dot RGB equals to RGB red plus image I j dot rg, and also a shortcut for you guys to just be familiar with. If you guys press Control and space together, you will get shortcuts to what to press. So G plus image ij dot rg and then B. So once again, it's Control space, and then what we want to do is divide it by 3.0. I'm using a 0.0 just so that we don't truncate the value that we come up with, because if we use an integer value divide by an integer value, we won't have decimal places, and now that we have the decimal places, we can round it up. So round using the round function, and to make sure our round function works, we have to include math.h. Alright, so then we have RGB, okay, and then we have to update our RGB values for red, green, and blue. So image ij.rgbt red. I'm not sure if you can do this. Let me just try. I don't recall trying this before, but let's see. Green equals to image ij.rgbt blue equals to average RGB. Alright, so let's see if this works. Make filter, and let's run an example that they have given us. So /filter -g, and let's update the curtyard.bmp file. Okay, let's look at our updated file, images, and oh my, this looks horrendous. I think we have done something wrong. Let me just double check. Oh, okay, I noticed what went wrong. We're supposed to do this first, okay? So we want to add it first and then divide it by 3. So it was just a careless mistake. Let's run it again, make filter. Let's try this again. Grayscale, and yeah, now it looks so much better. So what was happening just now is that this image.rgb blue was being divided first by 3 and then being added to the rest. Now what's happening is we are adding all of this 3 together and then divided by 3. So yeah, just a careless mistake. Moving on to sepia. So for sepia as well, the walkthrough gave us the solution to how to implement it. And there is basically a formula that we can use. Alright, so sepia rate is gonna be 0.393 times original rate and whatnot. So this is basically the formula that we'll be using. So for this as well, we'll be using a for loop to index into every single pixel in the image. So int I equals to 0, I less than height, I plus plus. So for int j equals to 0, j less than width, j plus plus, and yeah. Okay, so how are we gonna do this? And also for this, right, when I was first doing it, I forgot about a consideration that we are supposed to take, because I watched till this part of the video and then I did my code and I found out that there was some issues, and that's because we are supposed to actually cap out the values to 255. As you can see here, this example that they give, if we do the calculations, we'll end up with an RGB values of more than 255, but then per byte, right? So because we are using uint8, 1 byte has a maximum value of 255, and if we put anything more than that, it will just cause some weird values. So we have to max out our values at 255, and you'll see what I mean in just a bit. But before that, let's just fill up our calculations. So let's have int sepia red, then sepia green, and sepia blue. and so sepia red is gonna be equals to 0.393 times image ij dot rgbt green red plus this part is gonna be pretty boring, so I'll just speed it up. Alright, so now we have completed the calculations for sepia red value, sepia green value, and sepia blue value. Now what we have to do is check if the values are more than 255, and if they are, we want to make sure that we cap it at 255. So if sepia red is more than 255, then we're gonna do sepia red is equals to 255, and similar for the rest as well. We can just do else if, but we could also do just if, but it's oh well. Green, blue, okay, so if sepia red is more than 255, sepia green or blue more than 255, I want to cap it out at 255. If we don't, then it's gonna be pretty weird. You guys can try it out for yourselves. If you guys don't add this, the answers will be a little weird, because right, the maximum for a byte is 255, and if it goes more than that, it will actually reset. So when it goes from 255 to maybe 256, the byte will become 0, then 1, then 2, then 3, then 4 and stuff. So the image is gonna look very weird. So initially in my program I didn't have this when I was just doing it for myself, and I went into this error. Okay, so now that we have this, we can update the original image RGB. So image ij dot rgbt red is gonna be equals to sepia red image ij dot rgt green is gonna be equals to sepia green, and image ij dot rgbt blue is gonna be equals to sepia blue. Did I type something? Okay, so that's it actually. Let me just make filter just to see if everything is fine. Okay, make filter. Let me try an example that they have given us for a sepia filter. So stadium sepia, and yeah, looks weird. Let me try to figure out why that is. Okay, so actually we can't use else if because it might feed the other cases as well. So it's just gonna be if this, if this, if this, because if you use else if, then if it fits this scenario, then it's gonna skip the rest as well. So let's try again, make filter, running again. Yeah, now it looks alright. So that's that. Now moving on to the next filter, which is gonna be the reflect filter. So for the reflect filter, Brian has also gone through that part, and the reflect filter is a little more simpler. We don't have this fancy calculations that we have to do. And so how is the reflect filter gonna work? It's gonna be basically us switching between the first index of the width to the last index of the width. So 0 and 10 is gonna swap, 1 and 9 is gonna swap, 2 and 8 is gonna swap, 3 and 7 is gonna swap, and so on, all the way until the center, and then at the center we stop. So here's how it's gonna be. So for int I equals to 0, I less than height, I plus plus. So the height is gonna be remaining the same. we'll be indexing through the entirety of the height. But then for the width, right, it's gonna be slightly different. So int j equals to 0, j less than width, divide by 2. So why this is the case is because, you know what, let me just type out the code first. And so j plus plus. And what's gonna happen here is we're gonna be swapping the first and the last. So it's gonna be and for swapping, right, we have to have a buffer. So in the video that in the lecture that David Mellon has gone through, he gave us an example of this buffer, right? So in this part of the lecture, the student required an additional glass so that he can store one of the colored waters, and then swap it into the two glasses. So just like that, we also have to create a buffer, and our buffer is gonna be of type RGB triple. So RGBT, alright, PLE, a buffer is gonna be, so we're gonna be creating a buffer just so that we can do this swap. So buffer is gonna be equals to perhaps the very first index. So it's gonna be image I j dot, actually we don't even have to dot it because we will be swapping the entirety of the image. So it's not just either red, green or blue, it's gonna be the entire thing. So we'll be storing the pixel in our buffer, and then what we'll be doing next is image I j I width minus j. Okay, so let's say j is 0, the width is, okay, sorry, and we have to minus 1 as well. So let's say j is 0, right? The width, let's say, is 10. So it's gonna be image, for example, of height 0 and of width 9, because 10 minus 1 is gonna be 9. So this and this is gonna swap. And then next, let's say we have j of 1. So the buffer is gonna be storing this value, and then we'll be swapping it with this 9. So it's gonna be width of 10 minus 1 and minus j, which is gonna be 1, which is gonna be 9. So here what we're gonna be doing is gonna be image I j is gonna be equals to the pixel that we want to swap it with. And then last and not least, what we want to do is to complete the swap. So image I width minus j minus 1 is gonna be equals to the buffer. Okay, so if you guys don't get it, don't worry. I'll just spend some time to go over the code and see how it's gonna work. Alright, so that should be it actually. Let's try using this reflect and see if it works. So make filter, and let's try this. Alright, so we created tower reflected.bmp. Okay, so sorry, it just took some time it was just a little laggy. So tower reflected BMP and the original tower looks about right. Alright, so now moving on to blur. So blur is gonna be a little bit more difficult, and so harder for me to explain. So let's move over to my iPad and I can explain to you what's the technique I'm gonna use to figure blur out. So if you guys noticed, we have a lot of pixels, right, that we want to blur. Okay, so how the blurring algorithm is gonna work is, for example, we have this pixel. Then what we want to do is take the average of R, G, and B of this, this, and this. So all 9 of the pixels we will be indexing into them, and getting R, G, and B, and then getting the average and filling up the center with the average. Okay, so how can we do that? So first and foremost, we have to index into all of the individual pixels in our image, right? So what we've been doing so far, we have to use a for loop to index into the height, each of the index in the height and also the width. But apart from that, what we also have to do in the blur filter is that we have to index into the pixels surrounding it as well. So for example, we have this, we have to index into this, and this. How we do that is, for example, we this is pixel indexing 5, 5. Okay, so let's say it's 5, 5. How we'll be indexing into the pixels around it is gonna be looping through this, looping through all of it. So, and how we'll be doing it is we have 5, 5, right? We'll be starting from 4, 4. Okay, and then we'll be moving on to 4, 5, and then we'll be moving on to 4, 6, and then we'll be moving on to 5, 4, and then 5, 5, 5, 6, and then we'll be indexing into every single one of the 9 pixels we have, and then we'll be getting the sum of all the red, green, and blue, and then based on the sum we'll be dividing it by the number of pixels we index into. So you guys might ask, why not we just take the sum and divide it by 9? We can't do that because let's say we have this pixel here. This pixel, we only have this, and this. We don't have 9 pixels that we can take from. It's only 4 in this scenario. And let's say we have this corner. For this corner, we only have 6. We don't have 9. So for these edge cases, we also can use a method to figure that out. But let's just implement everything that I've spoke about so far. And so moving on to the code. First step is to index into all of the pixels we have. So for and I equals to 0, I less than height, I plus plus. For and j equals to 0, j less than width, j plus plus. And then what we want to do is index into the surrounding pixels. Okay, so like I mentioned, we have to index into so for example, we have 11, we have to index into 6, 7, 8, 10, 11, 12, 14, 15, and 6. How we do that is we have to update the I, we have to run another nested for loops, but this time it's on updated i's and j's. So like I said, let's say we are in the 11th pixel, right? So for the 11th pixel, we have to make sure we index into so for the 11th pixel, it's gonna be of index 3 and 3. We have to index into index 2 and 2, 2 and 3, 2 and 4, right? 2 and 2, 2 and 3, 2 and 4, and then 3 and 2, 3 and 3, 3 and 4, and then 4 and 2, 4 and 3, and 4 and 4. So how we'll be doing it is updating the I. So I is gonna start from so updated I, int updated I is gonna be I minus 1. Okay, and int updated j is gonna be j minus 1. Okay, and then we'll be adding it by 3 so that it covers the entire 9 pixels. So for int for updated I, yeah, we can add this inside the for loop. So I minus 1 updated I less than I plus 1, I plus 2 actually, because we want it to run all the way to here. So if it's less than I plus 2, it means that it went up to I plus 1, and updated I plus plus. And then for updated j is gonna be equals to j minus 1, updated j is gonna be less than j plus 2, and updated j plus plus. All right, and we will be having a variable, like I mentioned earlier. We will be having a variable which is going to be called the sum of red, the sum of green, and the sum of blue. So let's create and we don't need these two anymore because we already declared it later on. So int, okay, but then we have to have int sum of red, we'll be just initializing it to 0, sum of green equals to 0, sum of blue is going to be equals to 0. And then we will only be running it if the updated I is more than is either more than 0 or 0, because if it's less than 0, we know that it's out of the scope. Okay, so if updated I is more than 0 and updated j has to also be more than 0. Apart from that, we also want it to be less than our width and our height. So updated I has to be less than our height, and updated j has to be less than our width. Okay, and so if all of these conditions are met, then we know that, oh, we can proceed on with doing our calculations. And for this as well, we have to make sure we know how many pixels that we are taking the sum of, right? So we also have to have another variable which is going to be called total pixels, and it's just going to be starting from 0. So it's going to be sum of red equals to plus equals image. So sum of red is going to be updated I and updated j. All right, dot RGBT red. And same for sum of green and sum of blue. And after looping through all of the 9 pixels, if there are 9, or even like 4, if we are at either of the corners, then what we'll be doing is finding the average and inserting the average into our original image. Okay, so oh yeah, also apart from that, we have our total pixels, right? So total pixels is gonna increase as well, so that we know how many pixels that we are taking the average of. So now what we'll be doing is actually, right, something else that I forgot to mention is that this image, we won't be updating it right here, because if we update it, it's gonna alter our calculation of blur, like they mentioned here. You might find that blurring one pixel ends up affecting the other pixels as well. So we won't be updating the actual image itself. We will be updating a replica of the image. So let's create a replica. RGBT RIPLE height, sorry, image replica height and width. Okay, And in the very end of our calculations for all of that, what we want to do is update the replica image. So image replica I and j dot red rg. Red is gonna be equals to sum of red divided by the total pixels. And since we want it to be the most accurate, we can change this int to float, and then we can round this number either up or down. Okay, so this is gonna be same for the other colors as well. Alright, so now at the very end of our calculation, either for the average of 9 pixels around it, or either 4 or maybe 6 pixels around it, then we will be updating the image replica. And then at the very end of our for loop, after we have gotten the blur image for all of the pixels, what we'll be doing is copying over the image replica into the actual image. So for int I equals to 0, I less than height, I plus plus, for int j equals to 0, j less than width, j plus plus, and then we'll be doing simply image I j is gonna be image replica, image replica I j. Alright, so that should be it actually. Let me just make filter and see how it goes. Make filter works alright. Let me try yard blurred, see if it works. Alright, so we have a blurred image. Okay, it looks pretty blurred. Should be correct. Now let me just run check 50 on all of them and see if I have any issues with them. Alright, so guys, I figured out the issue, and it's because I chose more than 0. It's supposed to be more than or equals to 0. So let me just fix that. Make filter, and let's just do a check 50 again. Just a little careless mistake. Alright, so blur seems to be fine, but there seems to be some issues with sepia. Let me try to fix that. Alright, so for sepia, right, I feel that what happened was we used integers instead of floats. So I think if we use float instead, what's gonna happen is we can round the values. So let's try that. So round, and round. I think that should be it. Make filter. I figured it out because like my answer and their answer are pretty close. It's just like slightly off by either 1 or 2. And yeah, that was it. Okay, so thank you guys for watching. If you guys enjoyed this video, hit the like button and subscribe. If you guys have any questions, comment down below and I will try to help you guys out, and see you guys on the next video. Bye bye.